Okay, let me start. So basically, guys, from this course, you have learned uh, from basics. For example, part one. Part one. Let me have this white paper. Screen white paper. So basically, guys, logic digital, we have learned part one. So part one is something to do with combinational logic circuit, right? So basically, ultimately, you will have design a circuit that consists of basic gate, right? Basic gate, and there is no memory element, okay, memory element. So basically, in the design, the most important part is you have your part K-map, K-map, and then from the K-map, I want to have my equation, minimize equation to whatever that in terms of sum of product or product of sum, right? Uh, and then your chapter 6, basically, you learn about medium scale integrated IC. So basically, you learn adder, right? Adder. You learn comparator. You learn marks, marks. You learn demarks. You learn decoder, okay, decoder. You learn encoder, okay, and encoder. Encoder. And then part two, okay, part two, basically we learn how to design a sequential circuit. Sequential circuit. So basically sequential, you have your basic gate, basic gate, and you have your feedback element, okay, feedback element, or regenerative part, which is mostly we refer to memory element, right? Memory element. Then, uh, so the most important sequential circuit, I have counter design, which I have asynchronous and synchronous counter design. Okay. So upon knowing this concept, basically you have to apply, okay, apply one case study, so that I can try to govern all information that you learned from part one, okay, basically this one, K-map and also the MSI, and I try to combine together with a counter, okay, counter. Counter. Okay, counter design. Okay, design. And also the MSI IC. Now, so I come up with problems that I'm trying to transfer one uh, transfer from two source of computer, resource and destination from a remote distance. And then I define a basic how many packet to transfer. And then from there, I define rules, uh, how to enable the counter, and then start to simulate. Okay. So I come up with this title called Network Packet Transmission Monitoring System. Right? Okay. So what is the expected outcome from this exercise? So basically, as I said, we want to have application of real case outside room, right? Classroom. So try to imitate outside classroom problem. before this, your senior maybe have already implement the lift building design, key design, whereby I can what do you call that? I can determine what level floor that you want to intended to go and upward and downward, right? But now, as I said, I try to formulate a new case study. So real case problem. Okay, and try to relate whatever information that you have learned from this subject. So, in order for you to complete this task successfully and I mean, very good solution, and then you do as a group, and try to have self-exploration, right? So this is important. And then, well, I will give a basic solution, the idea, and then try to improve. Okay, try and to improve new features in your system later on. So that's why your creativity problem comes in. Okay, so that's why we would rather you to do this as a group, as group. So the maximum probably 4 students per group, right? And of course, in terms of well, in terms of good marks, so you should produce a good idea solution, right? Good idea solution, and then be able to present your idea, okay? And this presentation, so you need to involve all your members, right? So as a leader, one of the member, you will be appointed as a leader, and then from I mean, the leader will distribute the job, the task of each member evenly. Okay, and then reporting. Reporting means you present a full documentation report, right? And then, of course, you need to demo your system. Okay, how your system work, right? So this is the overview of expected what you guys should do at the end of this project. So this is the requirement of conducting project. As I said, this is a group assignment, and maximum student. This is I mean the suggestion. Maximum 4 students. Minimum could be 2. Minimum could be 2 students, right? Maximum could be 4 students. And then, well, you have to appoint a leader. Okay, appoint a leader of your group. Then a leader should what do you call that? Plan to distribute tasks evenly among your members. So distribute tasks, okay, tasks among your group, okay, group. Then here, you should understand the case study. Right? And then, of course, from the understanding and try to design the script, right? Script. The word is design. Design. Do not copy. I mean, design by yourself. And then you prepare project report, right? I will show you the format later on. What is the, I mean, the content of your report. What the report should have, the content, right? And then, of course, you need to present your project. So here, you need to maybe form 10 to 15 slides. This slide, I mean, a summary of your works, and then you present. You do the presentation. So here, it depends on your lecturer. Okay. Sometimes if we have sufficient time, then we do it face-to-face presentation. And for me, I think I would I would suggest you to present offline, record that, and then share the presentation to me, right? So basically, the presentation is offline, offline presentation recording. Well, so in 10 and 50 slide, basically, you need to prepare a very good presentation format. Okay, so you can use available template. Okay, very nice template, and then customize with your own content, right? Each members, the word is each members, each members should take part in the presentation. So as I said, this is offline, offline video recording for presentation. Not only presentation, demo also the video, I mean, based on the video recording. Right. And then, of course, in the presentation, you need to demo your circuit, right? So do not give your circuit to lecturer, then you expect lecturer to understand how your circuit operation. So you need to demo how your circuit, the requirement, step 1, step 2, step 3, and then the expected outcome, etc. Right. Now, of course, when you record the video, right, then the size is big, right? The size is big. Okay. So, are you going to share? I mean, are you going to upload the big size of the video to e-learning? The answer is no. So, probably the best way is you upload. Okay, you upload to your YouTube channel. Okay, YouTube channel, and set private channel. Okay, private link. So private link means only a person that you share the link can see the your video, right? Private channel, private link. Okay. And then the link, okay, the link of the video, then you give to me, to me. So what you need to submit in e-learning. So this is the thing that you need to submit the learning. Later I will open e-learning. For submission. First is project report. So normally I prefer PDF, PDF format, and then presentation slide. Okay, you can convert to PDF as well. And then this one, the video recording link. Okay, video recording link. Okay, this one unlisted link. So it means that you don't set private, you don't set public, so unlisted means private, and then you share the link to me. Okay. And then lastly, the circuit DITS dot PBS. This is your DITS circuit, and then you need to publish in e-learning. So one group, only one submission. Okay, one group, one submission, only one submission. And the due date, we give you 1 month. So basically the due date would be 1 January 2025. So what 1 month is plenty of time, right? Okay. Provided you start from now, right? Now, so this is your case study, right? A group of computers in lab 1 are connected to a group of computers in lab 2 via one cable. So it means that I have one set of computers in one lab. Okay, lab 1. So probably in lab 1, I have 10 computers. Okay, 10 computers, and connect to one cable outside of the lab 1 and connect to another lab, lab 2. Lab 2. So see in lab 2, I have 10 computers. Okay, 10 computers. 10 computers. So this is the connection. And then here, of course, what devices you need to connect. For example, I have A1. This is computer A1, A2, A3 until A10, right? So this is a computer from lab 1. Then lab 2, I have here B1, B2, B3 until B10. So this computer and this computer. And then I select, for example, connection. I select connection between A1 to, let's say, B10. So computer A1 to B10. So this is your source address, and this is your destination address. Okay, so 1 to 10 here. So here you need to think about the connection of the hardware. So basically here, you use your mux and demux, right? I have here, for example, this is your mux n to 1. So I have n input and 1 output. And then at the destination, I have demux 1 to 1 input distribute or route to many, 1 to n. So basically this you want to have the connection using mux and demux. So that is in terms of hardware. And then how to choose computer A1 as a source and computer B10 as destination. So you basically you manipulate the bit select. Okay, bit select. So you manipulate bit select for mux and you manipulate bit select for demux. Then I can have my connection, dedicated connection. So this is in terms of hardware. And then later on, I want to define, okay, how many byte that I want to transfer. Okay, byte I want to transfer. For example, 8 byte, 8 byte. So 8 byte, or maybe 16 byte. So this is the maximum size of the packet that I want to transfer. Okay, and then before I enable the transfer, then I need to check the rules. So what are the rules that I need to follow in order for me to be able transferring a packet from lab 1 to lab 2, computer in lab 1 to lab 2, right? So that is basically the rough rough operation. Now, so this is the layout. I've already what do you call that? Put in a very good, simple layout. So lab 1 and lab 2. Right. And then you need to design and simulate circuit to execute packet transmission using this. Okay. Okay, I hope you clear now what the project all about. Now, so you need to think about number one, a hardware component, right? What is the component? Hardware component. Okay, hardware component. What are components to use? And then secondly, function. Okay, function. What function do I need to provide in the system? Okay, functions. So basically, this is the idea. Well, number one, of course, your connection should involve mux and demux, right? So basically here I have a computer. You need to model the computer, and the computer is generating the packet. The computer will generate the packet. Okay. So how to model this? And then connection marks remarks. Okay, remarks. This one, marks remarks. And then the components. What the component? Of course, when you transfer the packet, right? And then we have to have to count what is the receiving amount of the packet received. So we need to design counter. So counter is basically count up. Okay, why count up? Because the receiving side, once you receive byte, so byte will increase, not decrease, but will increase. Byte 1, byte 2, byte 3, byte 3, byte 3, byte 4 until maximum. Right? Then here, how do we know the packet received is already maximized? So you need to have a comparator function, right? And then here, the most important part is you know that counter. So what is the? I mean, the counter is based on flip flop, right? Counter is based on flip flop, and then how do we control the flip flop? Basically, you need to trigger the clock of the clock to the flip flop, right? So the moment you trigger the clock to the flip flop, then the counter will work. But here, if I can, if I can control the clock, so I impose a rules here, a rules. When the rules is correct, followed, then the clock will enable. Right? The clock enable. So this is called clock enabler. Okay, clock enable. So remember if you remember the flip flop, flip flop. Okay, this is your flip flop, JK flip flop, for example, right? Then in order for you to make the queue works, and then you need to trigger the clock. So I manipulate clock enable here to ensure the clock will, the counter will count up and stop. So I manipulate this clock. Okay, this clock. So this is very important element in this design, clock enabler, right? Enabler. I will explain later, right? And then probably I want to monitor, in terms of dashboard, okay, dashboard, during the transfer, I want to monitor whether the packet is already received successfully, right? Whether the function counter is good. So whether the computer is functioning. So basically, I need to monitor the activity of the system. So monitoring packet transfer. And then probably if I want to monitor maybe a fault, is there any fault? So this is advanced. So I can say fault detection is advanced, right? So for those who can do this function, it is good. It is good, right? Okay, I go one by one, right? So in terms of hardware connection, as already explained to you, so you use mask and demarks. In terms of count up counter, So guys, this is unidirectional counter. Okay, why do unidirectional counter? Because we want to monitor the packet received, right? Increment. Okay, packet increment, packet byte increment. So it is unidirectional. Means that there is no external variables needed in your design. Okay. So in your design, you need to focus to synchronous counter, right? Synchronous counter. Okay. Do not use asynchronous. Use synchronous counter. Okay. So means that the clock of your system is common. Okay, is common. Okay, this one is very important. Synchronous counter, and this is option that we will assign to dedicated group. whether you use JK flip-flop, D flip-flop, and T flip-flop, right? So these are the, the possible flip-flop, man. No RS flip-flop, man. So JK, D, and T. And then, of course, here, okay, comparator function. Okay, comparator function. Guys, comparator function here, we allow you to use a component, that available in the library. Components, comparator components that provide by this. Okay, if you still remember, you can also design comparator, for example, equality or inequality. Okay, equality. Then you can use either XOR or XNOR. Okay, but in your project, you are granted to use comparator components in the disk, right? Comparator is important here. Important. Now, then this one, clock enabler. So clock enabler, guys, basically I use either AND gate or NAND gate, depending on whether you want to enable, for example, this one or low. Okay, but in my example, I give AND gate for designing clock enabler, right? Okay. And then here for monitoring packet transfer, yeah, this is what monitoring packet transfer. I think this one something to do with monitoring. Monitoring means dashboard. Okay, monitoring means dashboard. And when you want to, for example, design interactive dashboard, maybe you need to use a component of MSI. This one is up for your, is up from your activity. And also here, display controller fun concept. What do we mean by fun concept? Right. For example, in your system, you say, okay, welcome. Okay, welcome. Welcome to, let's say, Mons data. So this is your system, right? And then you want to, for example, you want to light up the welcome text and Mons data maybe alternately. So like chasing lamp. So this is probably idea of interactive fun. Okay, so displaying fun. How to do this? Okay, welcome, and then light up off to light up off mon data light up off. So this is I call what do you call that? Fun concept of displaying some text. Right. So again here you need to use the suitable MSI. For example, DMAX. DMAX. I will show you in the basic concept. Basic basic skill. And then guys here, this is for monitoring. So this is advanced. Right? This is advanced. Right. Okay, now, so in terms of understanding operational, how does the system works? So here, guys, I divide your circuit, and your circuit, I divide into two. Number one, basic circuit. Basic circuit. So this is minimum requirement. Okay, what does minimum requirements means? Okay, for example, of course, the computer must be on. This is requirement. And then, okay, and then you change to synchronous mode and reset the counter, right? And then your clock enabler, this is the rule. Make sure power is on, and then source and destination are set, and then packet transfer byte is set, right? And then you ready, you can simulate by activating clock. Okay, the start ready button you push, and then you can monitor the packet transfer increment one by one. So this is basic. So this is called basic. Then number two, you introduce extra features. Extra features. What does extra features mean? For example, you introduce password. Password means that before you can transmit the data, maybe admin should key in the password, right? And then probably the other one, later on, in your data communication, maybe you introduce mode of data transfer. Okay, mode of data transfer. For example, maybe this is new, simplex. Simplex. Maybe this is half duplex, or maybe this is full duplex. Okay, I will explain this later, right? Or maybe, as I said, error detection method. Okay, error detection method. So this is called advanced features, where these advanced features is basically the improve from the basic circuit, right? Basic circuit. Okay. So first, you need to have your basic circuit, and then you improve your basic circuit. Okay, basic circuit, you introduce extra features. All right. Okay, so this is basically the basic operation. I already explained the basic operation before. Basic operation of, what is it? Okay, guys. So when I talk about basic operation, basically it is something to do with clock enabler. Okay, clock enabler. So this is clock enabler, whereby I have condition 1, okay, rule 1, and then rule 2, and rule 3. And then if rule 1, rule 2, and rule 3 satisfied, all one, and then I will send the signal to enable the clock. Enable the clock. So idea of basics operation and advanced operation, basically the rules. Okay, advanced operation, basically the rules. The minimum rules to enable the clock is called basic circuit. The advanced features you put in the rules, and then it is called advanced circuit. So basically you manipulating the rules to enable the clock. This is called clock enabler. Clock enabler. So I will show you later this one. Don't worry. So this is advanced features. So password, you use comparator, right? You use comparator. Comparator. And this is the, for example, new features that introduce full duplex mode. Okay. Later on, you will learn data transmission. Okay, transmission. Basically, I can categorize into 3. Number 1, simplex. Okay, simplex. Simplex, the simple analogy is like broadcasting, okay, broadcasting of TV, okay, TV. So this is your TV, right? This is your TV, and then you receive the signal, okay? So the way you transmit data only one direction. You just can only receive only. So this is called simplex. Okay. Mode number 2 is basically known as half duplex. Half duplex. So what is half duplex? So half duplex is basically like walkie-talkie. Let me erase this. Eraser, eraser. Where's my eraser? Oh, okay. Eraser. A pointer, eraser. Okay, half duplex means like a walkie-talkie. Walkie-talkie. So what is walkie-talkie? Means that, okay, one person can communicate to other person. And A to B, right? So only one way. So means that A talk to B, B just listen one way. Then B talk to A listen. So one way, in one way, but two direction, but two direction, Okay, the other mode is full duplex. Okay, full duplex. So what is full duplex? Full duplex means I have A and B communicate at the same time. You can transmit and receive simultaneously, right? Like your handphone, okay, handphone, So you can talk and then you can receive simultaneously. So this is full duplex. So maybe this is the mode of transmission that I want to introduce as advanced features in my system. Okay. So this is remember simplex, duplex, full duplex. And then here, as I explained before this, fun display. So maybe here error detection method. For example, you introduce even parity or odd parity. So let's say I want to define when I want to design the clock enabler here. One of the rule here is password. Okay, password. And then other rules is, okay, I set full duplex. Then maybe the other rule is I set even parity. So when I already, the password is correct, full duplex is correct, even has set, and then the clock will enable. This is called advanced features. Okay, advanced features. We just introduce new features in the clock enabler. Okay, clock enabler. Don't worry, I will show you in real circuit later. Clock enabler. Right? So this is guys, if you have any ideas of advanced features in your system, then just discuss with me, and then if is it okay, then you proceed, right? So this is called creativity of how you want to introduce new function in your system, right? Okay. Okay. So this is in terms of connection, connection. So for example, here I have 4 computer in A, maybe 8 computer in B. So it depends on how you design the layout later. And then I use mux. When you use mux, basically you need to look at how many inputs, that you want to use the mux. Similar with demux, how many output? Okay, how many output? Okay, it depends on the connection of the computer, Okay. Okay, guys, this is example of how mux and demux. And so in this example, I just want to connect two computer in lab 1, okay, lab 1 to two computer in lab 2. Okay, lab 2. Okay, look at how I model the computer. Okay. So this is my computer, right? Computer 1. And computer 1, I have two important item. Number 1, switch on. This is power on of the computer. This is number 1, right? Power on. Power on. This is for power. Power on, right? Off. And then secondly is this one. This is to model data generator. A data generator. All right. And then how to combine both? So I need to use AND gate, right? I need to use AND gate. Okay, pointer here. Right. So generator. So I combine model A1 with AND gate here that input data generator, and the power module. Yeah. So I have here two computer A1 and A2, and each of the computer modules I have this one, data generator, power. Similar with the destination, lab 2. So here, computer lab 2, I will have power. Power. So this computer will, the computer will active when power is on, right? Power is on. Okay, so this is computer B, and I have power. And I use max and demax. So this is max and demax, max and demax. And then what type of max? Since I use only two computer, so 2 to 1. Okay, demax 1 to 2. Okay, so this is in terms of hardware connection. Yeah, model computer. Yeah, maybe I should erase this. Right. So this is the connection of hardware. Okay. So this is model of computer 1. The model of computer 1, A1. Okay, this one A2, A3. This one, this one B1 and B2. Okay, done. Connection hardware done. So here, guys, again, the selection of your marks and demarks depend on how many computers you use. The number of computers you use. This is important. Computer you use. For example, if you have 5 computers, so what type of marks that you use? 5 computers. 8 to 1, right? So based on your design. And then count out function. What is the count out function? So basically here, in the source, source, you need to define the maximum byte packet to transfer, right? For example, I need to transfer, let's say, maximum is 4 byte. Maximum is 4 byte. So when I want to transfer maximum 4 byte, guys, if one output consider 1 byte, what is the mode of transmission? Mode of N here, transmission. So I have mode what? Mode 4, right? Mode 4. And then mode 4, how many flip-flop do I need to use? So 2 power of 2. Okay. Bigger, sorry, 2 power of eraser here. So maybe use the formula of this one, pointer, pen. So 2 power of n in is number of flip-flop, flip-flop. Bigger or equal mode. How many mode? In example, I have mode 4. Okay. So bigger equal 2 power of n. So n equals to 2, because this n is integer. N is integer. So I need to have 2 flip-flop. 2 flip-flop. So when I define maximum byte, my number is 4 byte, and then I need to design 2 bit count up. So I need to design 2 bit count up. When I design 2 bit count up, basically the state that defined by 2 bit count up is state 0, right? State 1, state 2, and maximum state 3. So I define for the packet count, so count up, unidirection. 0 to 1, 1 to 2, 2 to 3, and maybe I can recycle. Okay, then after you can imagine the state diagram. Then the next is what type of counters that you want to design, either asynchronous or synchronous. Okay, so in my example demo here, I use asynchronous, but in your design, you use synchronous. You use synchronous. Okay, right. So first, I need to define what is the maximum packet number. Based on the maximum packet number, I know the mode of the counter. Then I design, for example, here 2-bit count up, because mode 4. My maximum is 4 byte, mode 4. Okay, and then you can use this one. This is the flip-flop that you can use in the design. Right. So this is the components of basics system. Okay, if you look at this circuit, guys. Okay, of course, this is the counter that you want to design. Okay, counter that you design. So depend on what mode that you want to use. Okay, and how many flip-flop. Okay, so basically and flip-flop here. Okay, based on the mode of the counter. Right, mode of the counter. And so counter, this is count up. Now, and then here I need to define what is the maximum byte count here. What is the maximum? Okay, as in the previous, I say 4 byte, right? 4 byte. So 4 byte basically four state. Okay, 4 state. Okay, 4 state. What are the state? 0, 1, 2, 3. And then this is a 2-bit up counter. Right? So this is 2-bit. Right? And I have 2-bit comparator. And this is this definition. I mean, to define what do you call that? This is the maximum byte. Maximum byte. I show you in my circuit later on. And then here, guys, this counter, how does this counter works? As I said, I control the clock. I control the clock, right? If the clock is true, means that the counter will count up. If the clock is stopped or false, the counter will stop, right? That is the importance of the clock. Then here, this is the rules that can, through the clock. So this is called clock enabler. Okay, clock enable. Okay, if you can see here, this is my external clock, right? This is my external clock. And I use AND gate here. I use AND gate here, AND gate. The rule is if the counter, the status counter is not equal with maximum. Okay, so the rule of the clock is when the current count of the byte, okay, is not equal, it's not equal, pointer here. So the current packet count, okay, is not equal maximum. Okay, here is less from maximum byte. Right? The current of the counter is less or not equal maximum byte, then the clock will enable, trigger the clock. Clock pattern. when the counter is not equal maximum, this is max. Input switch is max. Clock is activated. If the clock is equal, stop. Stop the clock. When equal, stop. When not equal, activate. So this is simple rules, right? So the counter will work if the current, this is current of the counter here, compare with the maximum. This is the maximum. This is maximum. If the current less than maximum, clock is enable. Count up. If equal, stop. Disable the clock. So that is the idea, right? That's the idea. Okay. I hope you can understand this, how the basic operation works. All right. So this is the component. Okay, guys. Here, I design a simple 2-bit up counter, asynchronous counter, or ripple counter, right? Ripple counter. So this is as example, for your case, yeah, you need to design synchronous. So for up counter ripples means you don't have to use CAMAP, you don't have to use a table equation. You just need to have your configuration, right? A configuration. So if I can see here, I use what? I use positive edge triggered, then parity not equal, then goes up. So goes up, goes up. This is my T, okay, my T. So T always on, toggle mode is on, right? And this is my Q1, Q0, and this is my hex output for hex display. Okay. So this is a basic count up. This is just for illustration. And comparator here, basically I use this component comparator. This is component comparator that in the library, that in this library. Okay. You can also use XOR or XNOR. But I mean, why don't you just use the comparator? It's very simple. Right? Okay. So here, guys, this is input from your input. So this is to define maximum byte, right? And then for the here, for the input from the counter here, since I use two bit, so I just use this and this wire, B0 and B1. The other two, I just I mean, what do you call that? I just connect to the ground because I just only use 2 bit. Okay, 2 bit. Okay, so this is comparator circuit. Okay. Why I use this inverter? Okay, the meter is simple. So the idea is if the maximum packet, maximum byte, the counter of the current status is equal to maximum byte. What happened? So I will have 1 here, right? So 1, it will 0. So this 0, I will connect to the clock enabler. Okay, the idea? If the input of the comparator, the input is some coming from counter here and coming from packet, maximum packet. If both are equal, then I generate 1, and then I flip to 0, and this 0 I will connect to the clock enabler AND gate. Okay, 0. 0, and then I get 0. So when 0 here, and then the clock will disable. So this is the idea, and this is the idea, right? So function comparator here, what to compare? So this one, maximum packet number. Maximum packet number with what? With current packet count. This is important, right? Okay. And these are the rules. The rule of what? Rule of clock enabler. Clock enabler. So what are the rules? If the packet number count is not equal with the maximum packet, then counting, then continue counting. Else stop. Else stop. So this is the rules, the rules of the enabler. Okay, and then a comparator you can use for example, password detector here to compare your input value with the memory value. If the same, then the password is correct, then you can connect to the clock enabler. Right. This is clock enabler. Clock enabler, please understand. So here, guys, I use AND gate. I use AND gate. All right. Okay. This is the basic rule of clock enabler, and this is the advanced rule. Advanced rule, Okay, basic rule, power is on, comparator counter is true, and then enable the clock. If I want to make it advanced, I add another security, password true, or maybe I choose full duplex mode. If both true, then enable the clock. And here, the rules, it depends on your design. I mean, the features that you introduce for clock enabler, Clock enabler. Okay, never mind. I will show you the circuit later on. So this is the clock enabler rule. I think I've already explained this before. Make sure power is on, right? Power is on. This one maybe destination, source destination is ready. Maximum packet transfer ready. When then ready button ready, and then you can start pushing the transmission. Push the clock to start transmit. Okay. I think this is the clock enabler, as I mentioned before. Okay, so here basically the trick is I want to control the clock. If the clock is on, then counter will count up. If the clock is off, then counter will down. So I just manipulate this trick. Okay, so this is the clock enabler. I use the AND gate. Okay, so if all the rules is correct, then the clock is enabled. If the rule is incorrect, the clock is disabled. Okay, so I use AND gate. This is packet monitoring. Okay, this is only system. Power on, mode transmission okay, completed counter okay, script okay, etc. So this is only the advanced features for dashboard. Dashboard. Right? So this is like, as I said, remember the display, interactive display. Interactive or fun display concept. So basically here the idea is this is one text, right? This is one text. This is another text. Okay. And then if I want to make the light on alternately, so how? So I want to supply the VCC here, VCC supply to this LED alternately. So how to get alternate supply? I use concept of DMUX. DMUX. Here, DMUX. So DMUX input is 5 volt here, and then I control this one, this bit selector alternately 0, 1, 0, 1. If I put 0 here, and then this LED will light up. If I put 1 here, then LED is up. So I control alternately 0, 1 here in the bit select, then I can have fun concept. of display. So I use here clock, so automatically run, so this use Dmux. Okay, Dmux. And then, okay, guys, this is the complete circuit, basic function. Okay, please understand this. This is important. Okay. Number one, connection of hardware. Connection of hardware. Hardware. Okay, so this is lab 1. I have computer A1, A2. This is the model of the computer as I discussed earlier. I have generated data and power on. I use Mux here 2 to 1. I connect cable and this is Dmux 1 to 2, right? And here I model the computer of recipient, receiver. So this is bit select, bit select here. Monitor, pen here. Okay, this one. Pointer, erase. Guys, you can, I already share this document to you. Okay. So this is bit select. Okay, this is bit select. To select the source. And this is bit select to select destination, right? And then this is the counter 2-bit count up. This is the clock enabler that I control the clock. This is the clock coming into here. Clock. I control this. This is the clock, right? And then what is the rules? What is the rules for the clock enabler here? Look at what is the rule. Number 1, I use OR gate to monitor on, switch on. Switch on from source. This is computer source, and this is power on for destination. Okay, so in order for data being transferred, of course, both computer must be on, right? So source must be on, either one. Destination must be on, either one. Then 1 and then the rules is true. Computer is on, then rule is true, right? And then what else? The rules. The rule is maximum count. So this is maximum count. Okay, byte. Okay, I define the maximum count byte. So this is the maximum definition, and the status of the counter here. I compare. This is comparator, right? Comparator. If not equal, so 0, then become 1. Now, all the rules here, for example, the switch is on here, all the rules okay, then I have 1, 1, 1, 1, 1, I enable the clock. If the maximum byte is equal with the, with the current byte is equal with the maximum, what happened? It become 1, 0, then 0, become 0. So stop. Stop the counter. Okay, try to understand the logic, standard logic. Okay, guys, I have already what do you call that? Okay, I have already give you the what? The full circuit. This is only for understanding the concept, not the actual one. The actual one you need to design. Okay, here as I see. Okay, so this is my Mux and Dmux, computer 1, computer 2, A1, computer B1, B2 receiver, and then this is the clock enabler here, right? Clock enabler here. This is from computer 1 on and lab 1, computer 2 on, right? Then here, this is other rules. This is what? This is a pulse. means that if I want to transfer, I need to, this is push button, look up here. This is push button. Where is this one push button? Where push button? This is push button. Push button, not switch, push button. So I want to replace with the clock here. So the moment I click the push button, as if that I give clock to the enabler. Right, this is push button, not switch. This is ready transmission packet data for maximum input. If I can see here, so this is my maximum input packet, and then I compare with the current output of the counter here. The current output from here, Q0 and Q1, right? And output, and then okay, this is the clock enabler, as I said, AND gate, and then connect to the clock here. Clock here, clock here. Okay, let's try. So here, guys, my maximum packet, because of two bit here, so maximum is 4. No, 4 state 3, 0, 1, 2, 3. Maximum is 3, right? 3 byte. 3 byte. Okay. Now I start to what do you call that? I start to on. So I save and I simulate. Okay, guys. So first, what you need to set for the counter? What you need to set? You need to change the mode of the counter to synchronous. Why? Because I need to have clock effect. So synchronous mode. So how to set synchronous mode? The counter, both must be 1. Clear bar and preset bar must be 1. Right? Okay. 1, 1, preset bar 1, clear bar 1. So if I change this clock here, synchronous, this is asynchronous input, both 1, 1 means that the flip-flop is running under synchronous mode, right? Synchronous mode. But here, guys, if I set 1, 1 here, the counter here change to maximum. The requirement is the counter must starting from 0, reset. So what should I do? So I need to change. I want to clear it. So I use asynchronous input. Clear 0, then preset bar 1. This is active flow, Clear 0, preset bar 1, then the reset. Then after that, I need to change to this one. I need to change to what do you call this? Clear bar 1, preset bar 1. Then here, the clock is functioning. Okay. Now, why don't the clock is the counter is up? Because I still not activated activating the clock here. I still not activating the clock. Okay. So I need now to activate the clock. How? So first, I need to change. I need to select source and destination of the computer to transfer. Let's say here, I select my computer A1. I select A1 here. A1 to, let's say, B2. So A1 goes to B2. So here, so I have to on computer A1. Okay, on. And then I have to on computer B2, on. And then after that, if I want to change, I want to test the connection from A1 to B2 here. So how? So maybe here I generate the data. Okay. So now computer A1, I already generate the data. Power is on, generate data. Okay. And then here, I want to route this. I want to route this to computer B2. Okay. So what should I do? What should I do? So I need to select the source destination, which is from the bit select. Here, this is the bit select of S0 to 1. So I select A1, so what is the value of S0 here? 0, right? So source 0, source address 0, because A1, and this is I0, right? A0, S0. Then here, what is the destination? B2. So what is my S0? 1, right? Because I need to transfer to Q1. So my S0 here equals to 1. S0 equals to 1. Okay? Here. So means that the routing is okay now. Computer A1, I transfer to computer B2 using mask and demask. Okay, here. Okay, if I select destination address 0, means what? Means that I want to transfer to B1, and B1 here, my computer is off, so I cannot transfer, right? So basically here, if I on this, then the B1 can receive. Okay, it depends on the source destination here, source and destination. So this is important. You control the address, source and destination address through bit select, bit select. Okay, now, okay, let's say I connect to here again. Okay, I connect to here, this one, and I change to destination 1. Okay, so means that I want to transfer from A1 to B2. Okay, done. So connection, I mean the can be established. Now we define packet, how many packet they want to transfer. Okay, here, since my counter design is 2 bit, how do I know? This one 2 bit, right? 2 bit count up. Then the maximum byte that I can define is 3, right? So here, this is my input of the, so I use this hexa input. Hexa is 3. So the maximum byte that I define is 3, right? Is 3, right? Now, if I put 3 here, the LED, what? This is 0, right? Z, okay, now, hold on. Okay, look at here. The clock enabler is 0, right? This is 0. Means that the what do you call that? The clock is disabled, and because the rules is not follow, right? Why not follow? Why not follow? Not follow because the output of the current status is 0, and then my input here is 3, so not equal. So not equal means 0 and 0. So disable the clock. Okay. Now, how to enable the clock? Okay, how to enable the clock? Then look at the rules. The rule is what? Saying the computer is on. Okay, computer 1 is on, and then computer destination is on. Okay. Rule for power is okay. Then what else the rules? The rule says, okay, ready button. So you just put on, on ready button. Okay, on the ready button. Now, so basically, here is 1 because the current of the counter is not equal at the maximum. So this is 1, right? So output for the comparator now is true. So the only left for the clock enabler is 2 is what? What is the only left? This is true. This is true. This is true. The only left is here. Transmission clock. So means that if I enable, I push transmission clock, I will see that the clock will count up. Okay. If I can see here, if I push the clock, so this is the push of the clock, then from 0 it will goes up. You can see 1, right? So packet 1 is already 1 byte is already received, and then I click push another clock here. So second byte received, and then push another clock. third byte is received. So if I can see here, maximum byte is 3. The current byte now is 3, right? So look at here, the clock is disabled. When the clock is disabled, what does it mean? Clock. The counter, the count up, stop. Okay. Then if I start pushing the clock here, if I start pushing the clock, it will stop there. Okay. If I clock it stop there, right? Stop there. So means that my packet transfer is already received maximum. So stop. Please stop. Okay. So look at the rules. Look at the rules. Now, and this one, if I push this one, I push the what? This one. Okay, push this one. So the clock here, look at the input. Blue, 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 but the comparator black. Black means 0. And then the output is 0. The output of the clock enable is 0. So the moment output of the clock enable 0, then it will stop the clock. When it stop the clock, then the counter will not work. I mean, stop. I mean, the maximum byte is already received. Then if I want to push, I mean to transfer another packet, clear the packet and clear the the counter, and then set to 1 again, and then start again the counter. Okay, I start again the counter. I push the button here, so it will count 0, 1, 2, 3, maximum stop. So it means that the maximum count packet is already received. Okay, so guys, this circuit is already provided in the this one. It's already provide, and this is already provided here. So what you need to do to have your understanding better, draw the circuit and try to play around the rules. How does the counter works? The counter works, right? So this is very important. Okay, please try. But here, guys, the counter is asynchronous counter, ripple counter. In your circuit, you have to design the synchronous counter, right? Now, okay, guys. In my what do you call that? In my simulation here. Okay, in my simulation here. So basically, hold on. Okay, this is 0, okay, 0, okay, this one. In my simulation here, source A1 goes to destination B2. So I just select source 0, destination 1. Now, in my simulation here, this to receive computer is not synchronized with the counter. What I mean is, the left side, I can see the data connection from A1 to B2 is true, right? But I can see here how to synchronize with the byte transfer received with the computer 2 here, computer 2. How to synchronize? Meaning that, let's say if I the counter is already maximum, so I stop the blinking. I stop the byte receive. How to do that? This is more realistic. Okay, let's say here this 0, 0. Okay, look at the connection. A1 to B2 is always blinking. Blinking means packet is transferred, right? But the counter here is already okay. Here the counter 1 increase, 0, 1. Look at it. This is 1, right? This is 1. This is 1. Okay, this is 1. And then when I push another packet, like I push another clock here, it increase to 2. Okay, this is 2. And then increase to 3. 3, right? So 3 means suppose the packet is already received. When already received, suppose B2 stop, right? B2 stop. Here, suppose when packet is already received, B2 must be stopped, but now the packet of the B2 is still blinking. So how to synchronize? Packet maximum there. Okay, stop the transfer. Stop the transfer. So how to synchronize the status of the counter with the packet received by computer B2? How? Any idea? So here, guys, I just use this, what do you call that? This one, model student. I just use sync data here, sync data synchronization. So what I do is, what I did was, from my output of my marks, okay, I end with clock enabler here. Okay, if the clock enabler is true, then it will enable the transmission. Again, if the clock enabler is true, so this is one, right? So yeah. I use the pen. This is, I mean, this is to have a realistic transfer. Yeah. So here pen. Okay, so this is coming from clock enabler. The clock enabler. The AND gate. Okay, the AND gate from clock enabler. So when the clock enabler is true, the counter is up. Okay, counter is up. When the counter is up, then the data here is true. When the data here is true, then the destination is true. When the clock enabler is false, the data here is false, 0. Then what happened? Stop. Stop the receiver. Then it will synchronize. The receiver animation of the B2 computer will synchronize with the status of the counter. So when clock disabler, when clock enabler is false, counter stop. When counter stop, transmission receive B2 stop. So that's the idea, right? Then I want to change the modification. I want to change the modification. How? How to change the modification? Okay, so I go back to my circuit here. All right. So is it stop? Oh, I stop. Then I need to have this one. Okay, I disable this. I disconnect this. So I just put one circuit N component N here, right here. So this is output of the marks, right? And I have to connect to the clock enabler. So where is my clock enabler? So this is my clock enabler. This is my clock enabler, right? Enabler. Then I need to connect from this clock enabler to this sync data controller. And sync data controller here. Okay. And then the output of this sync data controller, and then I connect to this one, to the DMAX, right? DMAX. So this is my data controller. Okay, my data controller. Right, data controller. So this is SYN controller. SYN controller. SYN SYN controller. Right, controller. Okay, here I just put. Okay, this one. This is SYN controller. So this circuit N basically enable the if the packet count maximum, stop the animation. So that is our aim, right? So please save, and then I try to simulate again. Simulate, so simulate. So first I need to change the counter as synchronous. Preset clear must be 1, right? Okay, this is maximum. Reset it is 0. And then, okay, I need to follow the rules. What the rules? The rule says, okay, define the maximum. They say 3, the maximum is 3. 3 byte, 3, 0, 1, 2, 3. Okay, state 0, 1, 2, 3. And then what else? Okay, computer is on. Let's say I want to transfer from A1. So I on A1, let's say I on B1. I on B1 here. So 0 to 0, So A1 to B1. Okay. So here my source destination is 0, destination is 0. So correct, So source is 0 because A0 to B0. So 0, 0. Select, Okay, just nice. And then here, what else? Okay, I've already defined the max pipe. Okay, then, ready. Ready a button. So I put ready 1, 1, ready. And then, the condition is all met except the push button transmission on. Okay, transmission clock. So the moment I click the transmission on, what happened? Oh, yeah, data generated. I have to generate my data. Where is my data here? My data, this one, I generate my data. And then the destination is 0. Synchronous, in. Why the output here is not working, B1? B1?
The data for A2 is on.
Sorry?
Maybe because the data for A2 is
The what?
A2 data is on.
A2, A2, A1. Because my source is 0.
Maybe because the data is also
Huh?
the data for A2 is on. So maybe that's the problem.
Why? It's not working. It's not working. 0, 1, 1, 1. Do I miss anything here? Do I miss anything here? A1 source suppose 0. Here is 0, right? Source 0. No, source. What about? It doesn't work, huh? Strange. Oh, something wrong.
Yeah, because of the data to the computer B need from the enabler. Enabler now is 0. Right.
Enabler. Where's my enabler?
Down there.
Down, down.
Yeah. Clock enabler is 0. So means
Ah,
that, so
0.
yeah, you need to trigger transition, right?
Yes.
So trigger transition,
Yeah.
enabler 1, then you got the
Yeah, you are correct. You are correct. Because now the scene is the received data from B1 is already synchronized, right? Synchronous counter here, synchronous controller. I call it a synchronous controller. So I have to enable the clock, then the packet B1 will receive. Okay, you are right. Now here, okay, I know this already. So my intention is from A1 to B1 because this one, A1 A1 to B1 because select 0 destination, source 0, destination 0, A1 to B1, now I enable the clock, okay, so 0 first packet, okay, look at the blink of the B1. So 2, right? And then this is look at the B1 here. The moment I push the the push button there, then 3. Oh, 3 stop. Okay, I reset again. Okay, look at the blinking, blink of B. Look at the blink B1, B1 here. Okay, just look at the blink, right? Blink. Oh. So transmit clock. Okay, 1, Okay, blinking, right? B1 blinking, right? 1, and then it's already 3. Sorry, it's already 3. Okay, guys. Anyway, you can try by yourself because I define the here. Okay, clock. So okay, blinking.
Yes, yes, can see the blink.
Yeah.
Can see the blink.
This one here, I need to have 1, and then okay, and then 1, 2. Tapi tak blink eh. Okay, guys. The secret is there. Try by yourself. Then try to simulate by yourself. Okay. So this is I introduced synchronous counter with the packet receive. Right. Okay. Then okay, this is the scene data. Okay, guys. Your circuit here. Okay, your circuit at the end circuit here. Basically, you are the one that knows how to operate your circuit, right? So I request you to have a manual instruction here. When you submit your circuit, you have your manual instruction here. So manual instruction basically tell others how to operate your circuit. So each of the circuit should have manual instructor, right? So this is manual instructor. Yeah? Okay. This is another advanced fault detection. You think by yourself how to make it advanced. This is only idea, right? Okay, guys, if I want to, let's say I want to, if I want to introduce half duplex or packet comparator and password, where should I adjust my, where should I adjust my this one? So I just introduce more rules to enable packet, right? For example, here I introduce one comparator to detect to set my password. So output of the password I will go to input of the controller. That's number one. Or maybe if I set, for example, half duplex or full duplex here, so I may introduce, for example, I use concept of decoder. Okay, concept of decoder here, right? Concept of decoder. Then I define, for example, mode here, 00 half duplex or simplex, 01 half duplex, what 0, okay, again 0 simplex, 1 half duplex, 2 full duplex. So how to introduce that pictures? Then I need to define here, okay, one input. This is the code, code. So A and B, for example, A and B here, right? And then here, this is the code that I define. Simplex ke, half duplex ke, full duplex ke, right? See, And then, for example, here, I just enable the full duplex. So full duplex, for example, I define, for example, 10. 10 for full duplex. For full duplex. Full duplex. Duplex. Duplex means that two-way communication can occur in one time, right? So means that here, I need to put the input here, AB equals to 10 in binary. So A0, B1. So which of the output decoder pin here is for full duplex? Why not Y1 and Y2? Which one? So I need to have Y here, Y2. So Y2, right? So Y2 for full duplex. Full duplex. Full duplex. Full duplex. Okay, full duplex. Then here, guys, so this connection here, full duplex, and then from the output of full duplex here, guys, then I need to put in the clock enabler, right? I put in the clock enabler here. Put clock enabler. One of the input of the clock enabler is full duplex. Then, in order for clock enablers working, what you do? I have to set the mode of transmission as full duplex 10. Then this is true. Output of the is true. Then after true, what happened? And the clock enabler will work. So there is the idea of full duplex. So means that whatever rules you introduce, that is the advanced features for your correct enabler, right? So it is up on your creativity. For example, here introduce error detection method, even odd. So you need to be creative, eh? So this is system, what do you call that? System alternate and fun here. So let's say I run this, okay, save that. Look at it. If I run this, enable, look at the display. I use concept of DMAX here, VCC, and I supply to the display system here alternately. So I can get very fun system, right? Display system. So I control here, bit select 010101. So I can have my running chasing lamp like Hari Raya. Right? So this is this is one of the other possible output. Guys, it's up to you. What features that you want to introduce? It's up to you. And then okay, guys, this is already the what the project assignment. Let's say I have 8 group, 1, 2, 3, 4, 5, 6, 7, 8 group. Then each of the group should select only one. For example, group 1, maybe I assign this. Group 1, okay, use this design. Group 2, use this design. Means that all different group has all different case study, right? Different case study, right? Right. And this is for my report. Please read this. Times enrollment, specimen 1.5. And then title pages, the education, table of content, report content, reference, etc. Right? And then this is the report content. You have to have your introduction, background problem, then proposed solution, requirement, implementation, conclusion, etc. Right? And then, okay, this is the project timeline. Okay. So I have 7. So 1 month, 1 month. 1 month, it's a lot. So I think that's all, guys, for a briefing. Any question?
Doctor,
Yes.
for the flip-flop types, you will assign us for the groups, or we will choose?
Okay. It depends on the lecture. Maybe if I open, for example, first come, first serve. So I've already assigned group 1, do this, group 2, etc. Right? So maybe first come, first serve. It's up to your lecturer. But definitely all different case study. Okay, different case study. Any other question? So I think I stopped the recording.